Okay, well, as the slide says, I'm Ethan Yonker, but most of you probably know me by my screen name that I use on XDA and on IRC and so forth as Destroy. I am the lead developer of the Team Recovery project, or TWRP as I like to call it. Some people call it TWRP, doesn't really matter to me what you call it, but show of hands, how many of you use TWRP? Good, good. How many of you don't know what a custom recovery is? Good, no one. Anyway, I have about 2 years of experience working on Android custom recoveries, and I've been the lead developer for about 1.5 years now. A little background before we get started and get into things. About a year ago, we rebased the Team Recovery onto AOSP 4.1, and we rewrote all of the partition management, which includes things like backup, restore, mounting, and wiping. And what I'm going to try and share with you today, since most people probably aren't that interested in doing custom recovery work yourself, is to give you some of what I've learned from my experience working on this project and working in a community type environment, so that you can maybe apply it to projects that you work on to help you become a better developer. Okay? First off, well-designed software should be portable. So when you're designing your software, you want to make it work well on as many devices as possible. That's one of the things that we've tried to do with the Team Recovery, is make sure that what we put in there is going to work on as many devices as possible. One of the things that I try to do is I actually will reject features that are very device specific. One of the things that I haven't fully made a decision on, but I'm planning on rejecting, is there's a patch set right now for Loki support, which only a handful of devices support right now or need it, and probably in another year or two we won't even see devices that still use that other than devices that originally shipped with it. If you start adding a lot of code or features to your product that are very device specific, you end up with a lot of extra stuff that you have to maintain and test going forward. And if you don't have all those different types of devices, or even if you do, you spend a lot of time trying to test your code against those kinds of things. If you have to do something that is device specific, I recommend that you try and find a way that you can provide a hook within your software. I know you can do that within Android apps, and what we did with within the Team Recovery is, you'll see here, this is basically the reboot function, and depending upon the different type of reboot, we have different shell scripts that can be run if they exist. And so if we have a device that needs some kind of custom way to tell the bootloader whether to boot recovery or to boot to the system, we can do that through a shell script instead of having to include custom code within the recovery. So, write code that's easy to read. Saving keystrokes by using small or unreadable variable names will not save you time in the long run. You'll actually end up spending a lot of time when you come back to your code a few months later. You'll look at it and go, okay, what did I really mean with this variable name? And to show you an example, this is some of the old code in TWRP 2.2 before we did the rewrite in 2.3. So we've got this struct here that kind of defines what we would store for a partition. And we've got MNT. I know what it means, it's the mount point, but as we get further down, we've got BLK and DEV. I think those are actually usually both the same, but I can't remember for sure because the variable names here are actually pretty terrible. So, and if we go a little bit further down, you'll see I started, as we added more things, we actually started using some variables that were a little bit more descriptive. One of the other, and we have here all the different types of partitions that we could have. And you'll see somebody decided to save one keystroke by going with DAT instead of data for the data partition. And again, for the boot partition, we've got boo. Boo! instead of boot. So, and it gets complicated though when you start looking at things like SDCEXT. This could be the external SD card, or on older devices that had small data partitions, it was common practice to actually create an ext3 or ext4 partition on the SD card. So I don't know for sure which one that one is, or maybe it's this one. So yeah, try and use some variable names that when somebody else comes through, or even you go through your code, you'll say, oh yeah, I know exactly what this person is talking about here. I'll show you some of what we did in the new system. This is part of what we defined for a partition. You can see we've got lots of variables for each partition, and most of the variable names are very lengthy and easy to read and easy to understand what they're going to be. Instead of BLK or DEV, we've got actual block device, the primary block device, and the alternate block device. Much easier for somebody else to come in that might say, download our source and want to make a couple modifications. They'll be able to read this and go, they'll know exactly what we're talking about. So, along the same lines, if you're writing a program where the performance isn't super critical, trying to save a few CPU cycles by using some convoluted algorithm or something may end up costing you hours in debugging later. Or if somebody else comes along and starts looking at your project, they may spend a long time trying to figure out what you were trying to do. An example that I came across, this is actually part of AOSP code. This is the MK font code that's actually in recovery, and this code is actually designed to create from an image file, it creates a font file. But if you look at the code, it took me quite a while to dig through this and figure out exactly how it was storing the font data. If you're a real talented developer, you may be able to look at this and figure it out right away, but what it really does is creates a real length encoded header file. So if you're writing an algorithm, try and come up with something that people can easily read and understand, unless you really need the high performance. Code that's easier to read, again, makes it easier to debug. So if you end up having a problem later on, if it's easier to read, it'll be easier for you to figure out what went wrong and be able to fix it. It also makes it much easier for you to get other developers involved, especially if you're an open source or community project. And even if you're not an open source project, if your project is going to stand the test of time, odds are you're going to get a couple of other developers involved in it too. And so if you make easy to read code, it'll be easier for everybody to be on the same page and everybody to work on your software. I also recommend that you structure your project carefully. Break each function into logical small subtasks. That way you've got different simple functions. And once you get a function perfected, a simple small subtask, a lot of times you never have to look at it again and you never have to worry about whether or not that function works right. You'll see in our new system, recently we had to add functionality to handle the F2FS file system that came from Samsung. It was really easy. I spent probably about 20 or 30 minutes actually adding this whole system. All I had to do was add a new function for wiping F2FS, and you can see the function right there. It's simple, nice, concise, and neat, and we have similar functions for all the other different types of formatting or wiping that we might do. So, copy and paste can be your enemy. I recommend that you never actually copy your code and write it twice. If you end up needing to duplicate part of a function, that should actually go into a separate sub-function so that you don't end up with duplicate blocks of code all over your project. If you end up with multiple copies of the code, if you end up having to change that code or fix it, you'll think, oh yeah, I found the bug, I fixed it, you put in your code fix, but oh wait, there's 2 other spots in your project where you're using that same code, and now you haven't fixed those other places, and you'll start getting bug reports a week or 2 later saying, oh, it's still broken. And you'll end up spending hours pouring through your code trying to figure out, okay, what code path did this person have to go through to end up getting to that block of code that I decided to duplicate instead of creating a separate sub-function for it. And good software structure, of course, makes it easier to read and easier to expand on the project later on. And of course, it also makes it easier for other developers to jump in and help out on your project if you've broken it down into nice, easy to read blocks. You should also try to make your project as flexible as you can. Before you start your project, plan ahead. When I was actually getting ready to do the rewrite, I started thinking about what I was going to do with our rewrite, probably 2 or 3 months in advance of actually doing the rewrite. I was very worried, of course, at the time that it was not going to go well, that I was going to end up introducing more bugs rather than fixing bugs. I spent quite a while actually thinking about it. Consider as many approaches as you can and choose the best fit for your project. So as I was thinking through it, I was thinking about, okay, how are we going to do this? How are we going to do that? How am I going to handle mounts? How am I going to handle all the different partitions, so on and so forth. Some other tips that I have for you: don't be afraid to throw out a bad approach. I spent quite a while worrying about throwing out our 2.2 code base and starting on 2.3, and I was very worried. But sometimes you have to do something wrong in order to actually find out how to do it right, and that's kind of what happened with the TeamWin recovery. So we kind of did it wrong in the first place, but when we did the rewrite, we really set out to do it right the second time. Along the same lines of not duplicating code, don't create two functions that basically perform the same task. One of the things that we had in our old code base is we actually had two different mount functions. This is the AOSP mount function, but we also had another mount function here called TW_mount. So sometimes I would fix a problem with mounting partitions in one of the functions, but it'd still be broken in the other one. So don't create two functions that essentially do the same thing for any reason, because you'll want to pull your hair out by the time you're done with your project. If you're making changes to an existing project like AOSP, which a lot of people that work on ROM development and so forth do, consider how the changes you are making might be affected when it comes time to merge future changes from the original project. One of the things that I did, and we don't actually use this code anymore, but when we did the rebase, you can see this is the AOSP mount function again, but I just threw in at the very beginning of the function to go ahead and use the mount function that I wrote instead of using AOSP and then return whether or not it succeeded or failed. So none of the AOSP code below this will ever get used because it'll end up using my function instead. That might be a good approach too, because if you're still going to keep this code around and you need to pull in future patch sets, they'll apply without creating as many merge conflicts, because you still have the old code there ready and waiting in case something comes in and changes. And of course, every line of code that you write is a line that somebody has to support going forward if the project is going to continue to have a life. So think about everything that you're writing and whether or not that's going to be something that's going to be easy to maintain and so forth. So I'm going to do a little bit of a code dive now and show you some of the things that we did in the new source code and kind of compare and contrast to what we did before. This right here is the header file for the partition management, and we broke it into two separate classes. So we have one class that's just a partition. So the data partition would have a reference for this class, the system partition would have a reference to this class, and so you'd have multiple copies of this particular class. But then we had a wrapper class that works around that, the partition manager, and at the bottom we created a vector of partitions. So the partition manager class has a whole list of all the partitions, and instead of using in the old system here where we specifically defined which partitions we could have, we now have just a dynamic list of partitions, so we can have as many partitions now as we want to handle. So if a device comes with two system partitions, I can have two system partitions without even having to change any code. And we don't have to deal with trying to figure out what these variable names mean and so on and so forth. We added a lot more information about each partition. So we have whether it could be mounted, whether it could be wiped, that kind of thing. We have, versus the old system where we just had a very limited list of items for each partition. We also added an idea called a subpartition. So on some of the devices, when we transitioned between MTD NAND and eMMC memory chips, we actually had some devices that had both. And so there was this concept of a data partition as well as a data partition. So the actual /data that had all your apps data might have been on the eMMC chip, whereas your APKs and so forth might have actually been on the MTD NAND. So we created this concept of a subpartition where we can say the data partition is a subpartition of the data partition. okay? So what that means is that when we run the mount command, it'll actually mount both partitions together because the two partitions are tied together. The same goes for backup or wiping. They will get mounted together, they will get wiped together, and so forth. And we can tie as many partitions together as we want. On some of the newer LG devices, they have 3 EFS partitions, which store things like IMEI and information that would be used to help connect the device to the data network. And instead of presenting the user with an option to back up EFS1, EFS2, and EFS3 separately, we can actually just present in the GUI a single list for EFS. But through the Recovery FS tab, which means no code changes, we can add a few flags to that, and TWRP will say, okay, all 3 of these partitions are tied together, and when you back up and restore, it'll do all 3 of them all at once, instead of having to present the user with these 3 separate options, and depending on the user to know that they need to back up all 3 of them together. I also wanted to show you, based on the structure that I showed you, this is the partition manager level. So if I wanted to mount the data partition, I would call this mount by path function with a path of /data, and it'll go through and iterate through the vector of partitions that we talked about earlier, and it'll, if the mount point /data equals the mount point of that particular partition, then we'll call the mount function for that partition, which then goes over to partitions.cpp. One second. And this is the actual mount function. And some of the things you'll see here is the first thing we do is we run the isMounted function to see if the partition is mounted. So we have a whole nother little function for that we can use to check any time to see if a partition is mounted. And if it's already mounted, we don't mount it again. We just say it's already mounted. We have another function that finds the actual block device that makes sure that we get the actual block device for this particular partition. Then we have another function for checking the file system type. One of the things that the TWRP recovery does that's a little bit unique is we'll actually use a block ID from libblockid to determine what file system is actually in use, instead of depending on the Recovery FS tab to tell us which file system might be in use. And we have a couple of different blocks of code, one for dealing with the exFAT, one for dealing with the OPS2, but for the most part, most of the partition types are just going to be handled by this mount function, which will use the actual block device that we got and the mount point, as well as the correct file system that we found. I think I'm actually in the wrong block of code. Right, this is the right line. So those are some of the things that we did with our, you can see some of the breakdown that we had with some of the different sub-functions and so forth, and how we really broke down each piece of that mount and how we tied it together through this tree of different classes. One of the things that I'm going to announce today is that pretty soon you will see the TWRP recovery included in an actual ROM tree. There's a new community ROM that we will be included with. And what some of that means is, first of all, it does not mean that the TWRP recovery will stop with compiling within other source trees. Doesn't mean that it always will, but for now it will continue to compile in other ROM trees as well. We also hope that the TWRP recovery will see better support due to having assistance from device maintainers. Right now we have probably 100 or 150 devices that we're trying to maintain, and it's getting to be quite difficult to keep track of them all and find testers for them. And so being involved in a community ROM like this will hopefully help get other people involved with the device testing. We also hope that it'll increase community involvement with other developers and collaboration between developers and ourselves. We also hope that this will provide us with better compatibility. Right now we're basically at the mercy of whatever ROM tree we decide to compile in, and so if they make a change that breaks our recovery, we have to try and work around it. But being included in a ROM tree means that we will at least have a little bit of say and some collaborative effort there, so that we don't have to be at their mercy. It also means the devices that have recovery and boot setups, like Sony devices or older Samsungs, will ship with the TWRP recovery included in the boot image of those devices. You can find out more about this ROM at the 3 o'clock discussion from Guillemot. I'm sure I probably mispronounced that, and I'm sorry. I'm Guillaume, right?
Yeah.
Good. Takes at least one horribly embarrassing moment for me to get a name right. I'm sorry.
I still just say Clody.
Fair enough. Usually that's what I do too. So does anybody have any questions? Don't be shy. If nobody has any questions, I can read the No David book from my 2-year-old.
What got you motivated on doing the team win recovery solution?
I started out in Team Win just as a tester because the original focus of the team was to get WiMAX working on the original Evo 4G, and the 2 developers that were doing most of the development, which was Richard Ross or TOCFH and Schinzel, neither one of them actually lived in a WiMAX area. So what they would do is they would compile code and then ship test versions to those of us that did live in WiMAX areas, and then we would perform the tests and provide the logs. When Team Win started to branch out into other things, we started doing recovery development, and recovery was in C, which is a language that I understood and had taken in college and so forth. And so I started getting involved with just small little pieces. You know, I'd ask for, okay, give me something that you think would be pretty easy, and I just, you know, started from there. So, and it just kind of ballooned, and eventually I was able to take over lead on the project and work on it from there. So.
I was just going to ask, I remember when the recovery first came out, it was by, I forget his name, he worked for NVIDIA. When did you take it over, and when did it become more your project?
It was Agrabin or Kevin Ruckert from NVIDIA. He was largely responsible for the original graphical interface, but he wanted to take the project in a little bit different direction than what the rest of the team wanted to do, and so he felt that it would be better if he left the project at that point. And so eventually the guys at goo.im started talking to me about doing recovery development because they wanted something that they could tie into with their app so that they could install some of the zips and so forth that people may be familiar with. And so they said that if needed, that they would help support me with, you know, maybe a device or something like that if needed. But so far, really, things have taken off very well for us, and that hasn't even been necessary. So.
How far do you think? Where's the future of the recovery script?
The open recovery script.
Yeah.
I don't see it necessarily having a different future than what it is right now. I mean, we'll continue to add additional commands, but I mean, if you're thinking like we might take it closed or something, no, that would not even be.
It's not going to be sunset, deprecated, or?
I have no plans to deprecate open recovery script at all. I don't, unless the only thing that I would ever consider doing is putting something in there where the user could confirm or deny running the script. But the honest truth is if somebody has gotten enough control of your device where they can write to the cache partition, you're screwed anyway.
Yeah.
So, and I've talked to people like JK's, you know, security experts about that, and they said basically if some app or something has got that much control of your device, it's already over. Using the recovery as a vector is just one of probably 1,000 ways they could do damage to your device if they wanted to. So, yes.
For someone just getting into TWRP, what would you recommend advice?
What kind of involvement are you thinking about if you're planning on getting involved? Are you looking at just porting it to a device, or are you looking at like trying to add more features?
Starting with the first one, but eventually hoping to do both.
With the first one, if you're wanting to compile TWRP for a device, there's a guide on XDA, and it's in my signature that you can follow. It's not for a super easy total beginner type of a thing, just because I don't think that that's something that I can safely provide. There's a lot of pitfalls and so forth, like HTC devices, you need to handle off-mode charging and so on and so forth. But if you're already at least somewhat familiar with like compiling, then you would be able to kind of jump in and follow that guide. And I'll admit that our recovery has like a lot of things like build flags, and then we've got flags that you can put in the FS tab, but I've thought about it for a long time about trying to simplify that process, but honestly, some of the advanced features that are available in our recovery you kind of have to have that in order to enable all those different things. So once you've got it compiling for a device, obviously, then, and if you need help, you can find us. You know, there's support information both in that thread and so forth. After that, getting involved, we have something on our webpage about how you can submit a patch through we have a Garrett instance that people can submit patches through and so forth. And of course, you can talk to us via IRC or whatever about something you might be interested in submitting to. So,
Is it possible one day that we can flash image files from your recovery?
I mean, technically, it would be, the question was if it's possible to flash image files from the recovery, and technically that's really easy for us to do. It's more just a matter of if that's really something that we want to allow people to do. Most of the time, if you're flashing images, the first thing you do is you flash a recovery, and most people then further flash images via update zips instead of just trying to flash them manually. But if there's a lot of demand for that, it would be very simple for us to add it.
I'm looking at augmenting some of your work with a client that helps feed its scripts. That's the reason why I asked about the recovery script. To where if you're staging or deploying 5 to 1,000
Right.
devices with custom ROMs, recovery apps, and so forth, you don't have a single guy doing it. You know?
Right.
It would be a client that would feed its scripts and reboot and keep provisioning.
Right.
Do you know if there's anybody already working on a solution like that? I love using somebody else's work because it saves me time.
So the question is related to using the Teamlin recovery and the Open Recovery script to flash multiple devices with like the same ROM. Like maybe working for a corporation or something, you want everybody to have the same software on their device. Right. You're not the first person that's actually asked me about that, and I don't know if anybody has something pre-built that they've shared for that, but it's really not that hard to create something like that. So, any other questions?
Can I pull your user debugger patch off of Garrett without breaking my build yet?
As far as I know, that it should be pretty innocuous. I'm pretty sure that user debug patch that you're talking about.
He's trolling you.
It broke my build before I left.
He's trolling you.
It worked for me, that's what I'll say. There's a reason why it's still in the review process.
Code review doing its job.
That's right.
Wasn't sure if you did an update since I flew out.
Sorry, you didn't. We
It's
egged
hard to
him
know.
on. We egged him on to do that.
Thanks. Thanks. Like I said, worked for me. But all I do pretty much
Cannot
is
reproduce.
make recovery image, and I actually have never actually built a whole ROM yet. I have all the stuff there, all I gotta do is type the command and it would build, but I've never actually done it yet. I live and make recovery image, that's pretty much all I do.
You broke my Sony.
It's probably not permanent.
Probably.
Any other questions? Okay, well, thank you all for coming.